Hi everyone, our lesson today is comparison between permutation with and without replacement for this formula and for this general formula here. So let's start with the first one. So here is permutation without replacement for n object taken n at a time, and here we have permutation with replacement for n object taken n at a time. Now for this formula here, without replacement, all objects are defined over a set. So we are not going to find repetitive objects here. So we have A, B, C, and D. We are not going to find D repeated or B repeated. This is a set, not a list, and not a multi-set. The second one, if the problem is asking us to generate ordered sequences, then we have to use this formula, and the same apply for replacement formula. The third one, n is equal to r, so number of object is equal to the number of symbol in the sequence or the size of the sequence for both formulas. And this means that the generated sequence has a length equal to n. So if we are permuting A, B, C, D, then the generated sequence must have 4 symbols, no more and no less. The main difference in applying this formula and this formula here is this first formula is applicable in case of no replacement, and this formula here is applicable in case of replacement. So without replacement means that when we are generating sequences, any object in this sequence is not going to be repeated more than once. So we are not going to find BB or EE or DDD, etc. Now, in the case of replacement, we are going to find that we have sequences such as BB, C, DD. So in such case, objects will be repeated more than once, and there will be sequences where objects are not repeated. So we are going to have both here. So this is really important to notice. In case of permutation of n object taken n at a time with replacement, we are going to have two portions of sequences. The first one contains sequences that has no repetitive object, and the other portion would have sequences with repetitive objects such as BB, DD, and so on. So of course here we have 5 symbols, which means that the object we are permuting are 5, A, B, C, D, and E. So in such case, we are going to generate a sequence like BB, C, D, D, and we are going to generate a sequence that has no repetitive objects whatsoever, B, C, A, D, and E. So this is permutation without replacement, and this is permutation with replacement. And definition of n and r, we know them in advance before. So now there is an interesting relation between PRNN and PNN we are going to find in the next slide here. So here we are using 3 objects to permute, and we are permuting these 3 objects 3 times with replacement, and we are going to get all these sequences. Now what do we notice about these sequences if we put them aside? That in these sequences we have two main parts. The first part, sequences that has no repetitive letters, just as ACB, BAC, marked in red, and the other portion of the sequences would have letters repeated such as AA and BB and CCC and so on. So we can divide this mother group into 2 subgroups. The first one contains sequences with no repetitive object, and these are the sequences, and the second one contains sequences with at least 2 repetitive sequences. So here we are having here 2 symbols repeated, and we are having here 3 symbols repeated, 3 symbols repeated, and so on. So what do we conclude? So the mother sequence here is a permutation with replacement of 3 objects taken 3 at a time, which is 27, as we have studied before. And the first subgroup contain 6 objects, which is permutation without replacement of 3 objects taken 3 at a time. And this group, which has repetitive letters, at least 2, is the difference between them. So what do we conclude from that? The difference between permutation with replacement and permutation without replacement is going to be the number of sequences with at least 2 repetitive objects. So if we subtract them from each other, we are going to get all sequences which has at least 2 symbols and more. Now we can generalize that. We write this difference here, and we write the formula in general form: PRNN minus PNN equal to number of sequences with at least 2 repetitive objects. Or we can write it in a different way: PRNN equal to PNN plus sequences with at least 2 repetitive objects. So in general, PRNN has always 2 portions, or we can partition it into 2 subgroups. The first one contains sequences with no repetitive object, and the second one sequences with at least 2 repetitive objects. Certainly here we are dealing with numbers, so PRNN is the number of permutation of n object taken n at a time with replacement, and we are going here to get 2 numbers: the number of sequences with no repetitive object plus the number of sequences with at least 2 repetitive objects. This is going to be really important for to solve a problem such as pick 3 and so on, lottery, and which we are going to see later. But we have to remember also that this formula here is applicable for n equal to 2, 3, and 4, and so on. So we are starting from n equal to 2. We are starting from 2 objects. We cannot permute 1 object. We have to permute 2 objects at least and go forward. So let's now compare between P and R here and P and R with replacement. The conditions to apply these 2 formulas: that the objects are defined over a set, that's for each formula, and the problem is asking us to generate ordered sequences, and that's also for both formulas. However, for the first formula, R, the range of R is from 1 to n. Why? Because this is permutation without replacement. So R could be 2, could be 3, and maximum n. So in such case, the maximum size of a generated sequence should be n. However, for permutation with replacement, R could start from 1 and reach n, and n plus 1, n plus 2, until infinity. So the sequence size in such case is unlimited here, while here it is limited for n. And we apply this formula in case of no replacement. So objects do not repeat in any generated sequence. We are not going to find AA or DD or EEE, etc. So for this formula, permutation with replacement, it is applicable in case of replacement, which means that some of the sequences generated are going to have repeated objects such as BB and DD and so on. So now again, portion of the generated sequences has repeated object in such case, and the other portion has no repeated objects. So we are going to have here, for this sequence, no repeated object, and for this sequence, repeated objects. And now we need to find the relation between permutation with replacement and permutation without replacement. So we are going to start with permutation of 3 objects taken 2 at a time with replacement. We have seen that before, and the generated sequence after the first withdrawal here and the second withdrawal here are these elements, which are 9 elements or 9 sequences. So let's put them aside So we have these 9 sequences here. So these sequences are divided into 2 portions or 2 subgroups. The first one, sequences without repetitive object, like such as CB and CA and AC. And the other portion of the sequences, or the other subgroup, are sequences that has repeated objects such as CC, BB, and AA. So now we have the first group of sequences with no repetitive object, and the second group of sequences with at least 2 repetitive objects here. So now let's see the number of all possible outcomes for the main group, which is permutation of 3 objects taken 2 at a time with replacement, which is 3 times 3 equal to 9. So we have here 9 sequences. And for the group that has only sequences with no repetitive objects, the number is permutation of 3 objects taken 2 at a time, which is 3 times 2 equal to 6. And now the sequences with repetitive objects is the difference between them. So PR minus P is equal to the number of sequences with at least 2 repetitive objects. If we were permuting for 5 objects, 3 at a time, then we are going to find CC and CCC and so on. We try to make this example as small as possible. So this difference between PR and P, now we are going to write in a formal way. P and R with replacement minus P and R without replacement is going always to be the number of sequences with at least 2 repetitive objects. We can write it in a different way. P and R with replacement equal to P and R plus the number of sequences with at least 2 repetitive objects. Or we can write P and R with replacement is always divided into 2 numbers. The first number represents sequences with no repetitive object, and the second number represent all the sequences with at least 2 repetitive objects. We have to remember that to apply this formula, n must start from 2 and r must start from 2 also. So that's it for today. Thank you for listening and have a good day.